Thank you all for joining us today. The webinar that we'll be talking about will be looking at how can you strengthen your OT environment, more and specifically looking at the role endpoint security plays. As you can see on screen, the title for today is Strengthening the Front Line, and we want to really explore what is modern endpoint security and how does it fit in OT environments, what does this mean for OT professionals, and how is this directly affecting your role as an OT professional. Before we get into the nitty-gritty of today's webinar, I just want to give a little introduction to today's presenters. So first of all, hi, I'm Jack. I'm an OT cybersecurity sales exec at M.A.C Solutions. So I've been with M.A.C for now roughly 2+ years. In this time, I've been able to help a wide range of customers strengthen their cybersecurity posture. I'm very lucky to be joined today by my co-host Ramsha. She's joining me today from our technical support team, where she is a senior technical service engineer. Ramsha has an extensive history of supporting customers. She's worked with them to understand the challenges that they are facing and help them to implement the solutions they have purchased to tackle these challenges.
Thank you, Jack.
So let's get rolling. I'm almost certain when you sign up for the webinar, you saw that there was going to be some key talking points. These are being, what is endpoint security? What does endpoint security look like in the OT world? What happens when OT security fails? Because we know these disaster cases do happen. So how can we highlight these? And most importantly, what can we learn from them? What can organizations do to better protect their endpoints? How would this actually protect the environment? And finally, what does endpoint security link to OT specific regulations? So this might be IEC 62443, NIST 2. We obviously understand there's a wide range of different regulations you guys are facing. So we wanted to see how can we drag this all together and understand where does this link to some of the challenges.
Endpoint security refers to the practice of securing endpoints, such as laptops, desktops, mobile devices, and servers that connect to a corporate network. These endpoints are potential entry points for cyber threats, so protecting them is critical for maintaining the overall security posture of an organization. When we say endpoint in an OT environment, we are not just talking about laptops or mobile devices like in IT. In OT, endpoints include devices like PLCs, HMIs, engineering workstations, sensors, and even legacy Windows machines running critical SCADA software. Imagine your company's network is like a neighborhood, and each employee's device is like a house in that neighborhood. Endpoint security is like installing locks, alarms, and surveillance cameras on each house. Burglars break into houses to steal valuables. Hackers break into devices to steal data or install malware. Even if the neighborhood has a security gateway, firewall, if one house leaves its door unlocked, it can still be targeted. So, endpoint security ensures each house is individually protected, not just the neighborhood. In the opening of the webinar, Jack mentioned that today we would be looking at what modern endpoint security looks like in OT. But before we can understand what modern looks like, we first need to look at how OT environments have traditionally been protected. Historically, the most common approach to OT endpoint security was air gapping. OT systems were kept offline and physically separated from IT networks and the internet. This approach worked at the same time for a few key reasons. OT devices were designed to run in isolation, connectivity was minimal or, in many cases, non-existent. And most importantly, threat actors were not actively targeting OT environments. However, it's important to note that endpoint security itself played very little role in this approach. Air gapping was a network design decision, not an endpoint security capability. Traditionally, organizations were not tracking endpoint behavior, were not monitoring for traffic anomalies, and had very little to no visibility to the assets running in their OT environment. For example, take an engineering workstation on a factory floor. It's air-gapped, has legacy antivirus installed, and hasn't changed in years. Now, a contractor plugs in a USB to upload a configuration update. Even though the environment is secure by design, malware can still enter, and traditional endpoint security would likely miss it completely because it was not watching behavior changes, or abnormal activity. The assumption was simply that air-gapped equals safe. Fast forward to today, IT and OT networks were now increasingly connected for visibility, efficiency, and remote access. And because of this, those traditional methods no longer work on their own and are leaving organizations far more exposed to cybersecurity attacks. So what can organizations to do better protect themselves? They can look to implement a modern endpoint security solution. A modern solution provides full visibility of all OT endpoints because you cannot protect what you cannot see. A lightweight, non-intrusive approach that won't impact uptime or safety, and a user-friendly central management platform allowing customers to easily control, tailor, and manage security in line with their unique OT environment. This is the shift from assuming endpoints are safe to actively providing they are.
Perfect. Thank you, Ramsha. Now that we've seen what endpoint security really looks like in the OT world, I think we need to look at what happens when it goes wrong, or an organization decides that it doesn't need this, or it doesn't correctly implement a solution that is OT centric. The scary truth is, it only takes one single compromised engineering workstation to spread ransomware through a plant network, allowing the intruder to manipulate operational logic, potentially causing production downtime. Sadly, this has been seen many times in the OT world. One we wanted to highlight with Norsk Hydro in 2019, when a Locker-Gogger ransomware entered through a single compromised OT adjacent endpoint. The attackers were able to worm their way onto 22,000 endpoints. This was across 170 sites, and it was across 40 different countries. Norsk Hydro did the right thing. They refused to pay any ransom, but because of this, the affected sites saw large amounts of downtime, and the attack is believed to have cost the organisation upwards of £45 million. This all happened when a user opened an email attachment that infected their workstation. Another example that we wanted to highlight happened in 2021 in the States this time, and Florida to be exact. The 15,000 people who called Oldsmar home could have been massively affected by severe injuries when an attacker remotely took control of an OT endpoint that controls the level of sodium hydroxide entering the water. The attacker tried to increase the chemical dosage by a whopping 11,000%. Thankfully, the operator at the time noticed the sudden change in dosage and was able to turn it to a normal level. If this wasn't caught, it could have led to severe injuries due to the high levels of acidity. The attack was able to succeed because the OT endpoint lacked authentication, monitoring, and segmentation.
Now that we have seen an increase in the number of attacks due to weak security on endpoints, what can an organization do? As we mentioned before, many organizations are still learning upon traditional forms of endpoint security, but this is where they are failing. They can now look to utilize solutions to help them better protect their endpoints. As well as this, the organization need to understand three core concepts. Number one, what is their level of risk? If disaster was to strike and they were to have their endpoints infiltrated, what would happen? What would be the financial cost? What would be the cost to their reputation? Number two, they need to know what their current level of cybersecurity is, where they have invested in before, have they completed an audit in recent history? Number three, and finally, they need to begin filling in the identified gaps for both their physical and operational security. So how can you achieve this? At M.A.C Solutions, we believe that we have a tool that can help you achieve this.
The tool that we believe will solve some of these problems is a TXOne Stellar. Stellar is an OT native endpoint protection platform designed to secure industrial and cyber physical systems without disrupting operations. It is purpose-built for environments such as manufacturing plants, utility, and critical infrastructure. These are These are organizations where uptime, safety, and legacy systems are non-negotiable. Stellar is context aware, leveraging an extensive OT application and certificate repository maintained in collaboration with industrial vendors. This enables it to recognize thousands of legitimate OT applications and enforce security without breaking industrial processes or generating excessive false positives. In short, TXOne Stellar delivers asset lifetime OT protection by aligning cybersecurity controls with operational reality. It removes the traditional trade-off of security and uptime. Ramesh and I thought it might be worthwhile just to highlight some of the key capabilities that TXOne Stellar can offer to you as the user and to your organization that is being protected.
One of the key strengths of TXOne Stellar is its ability to detect and stop malware in OT environments, and it does this using a multi-layered OT-focused detection approach that is specifically designed to stop both known and unknown threats without disruption operations. The first layer in cyber-physical detection and response, Stellar begins by building a baseline fingerprints of what normal looks like for each individual device. It does this by collecting telemetry from applications, system behavior, network activity, user logins, and device interactions. Once that baseline is established, Stellar continuously monitors the endpoint in real time. If anything unexpected occurs, such as malware execution, and unauthorized process launching, configuration changes, or suspicious behavior, Stellar can block that activity immediately before it has a chance to spread or cause disruption. On the top of this, Stellar uses two complementary detection engines. The first is a patternless machine learning engine. This detects previously unseen malware by analyzing behavior and characteristics, rather than relying on traditional signature updates. This is particularly important for air-gapped environments, where regular updates simply are not possible. The second engine is high-speed pattern detection, which scans for known malware using OT-safe, lightweight signatures. This allows for rapid detection without the heavy resource usage associated with traditional antivirus solutions. In addition to this, Stellar provides OT-specific application and certificate whitelisting. It uses a large repository of 8,000 to over 40,000 known OT applications, certificates, and processes, depending on the version. Because Stellar understands what legitimate OT software looks like, it can trust genuine ICS, HMI, and SCADA applications, quickly identify unknown or malicious binaries, and significantly reduce false positives and alert fatigue. Many of you will likely remember the Jaguar Land Rover ransomware attack. The attack slashed JLR's profits from £391.9 million to just £3.4 million, clearly showing how devastating ransomware can be when malware is able to execute and spread unchecked within an environment. This is exactly the type of scenario that behavior-based detection, real-time blocking, and OT-aware whitelisting are designed to prevent.
As Ramesh had just said, Stellar has the ability to operate in air-gapped environments. I'll go one more than this. It was actually explicitly designed to operate fully offline, allowing it to seamlessly work with isolated HMIs, PLC workstations, SCADA engineering stations, and contractor touch points. As Ramesh said, it has the ability to protect against malware without internet or network connectivity, ensuring safety when no signature-based updates can be downloaded. Despite this, despite the massive benefits that the Stellar One management server offers to the customer, it also has the ability to work in a standalone agent mode, meaning air-gapped endpoints can run a Stellar without Stellar One, allowing complete local control. The agent still enforces the lockdown modes, USB control, application allow listing, and behavior anomaly detection, even without that internet-based connection. We understand that these air gap zones can't afford downtime. Because of this, Stellar 1 applies protection without mandatory reboots. It neutralizes threats without stopping processes, and then finally adapts to resource restricted devices to ensure that they're safe.
A growing trend in the OT world is the threat posed by USBs. Part of the issue that we find in that organizations don't have a system set up to properly protect against USBs. The key themes that have occurred from recent attacks in the USBs remain the easiest method to breach air-gapped OT systems. They bypass the firewalls by relying on human behavior. It's now being reported that over 50% of USB malware attacks target industrial systems specifically. Stellar automatically blocks unknown USB devices, so when a USB is inserted that is not trusted, it prevents malware execution as the device cannot interact with the system. This allows the admin team to control which USB drives can be trusted by adding them to the trusted list via Stellar 1. Even if an infected device was able to connect, Stellar can scan USB devices for threats and blocks auto-run mechanism, stopping self-executing malware that is common on infected drives. Let's have a quick look at the video for Stellar 1. It will give you a basic concept and a view of Stellar 1. As you can see, the Stellar 1 is a user-friendly interface which can easily be managed by a wide range of the OT team.
Now, the all-important question that I bet is on many of your guys' lips is, how does endpoint security link to regulations? Because of this, we understand the challenge that lots of you guys are facing, linking your knowledge base to how this actually links to real world challenges like regulations. So we've highlighted some of the key ones, these being IEC 62443, NIST 2, and ISO 27001. And we've gone through these with a fine-tooth comb and saw where is the link between these and the points we made today. So one of the requirements that crops up in a few of these regulations is OT asset inventory and management. This is because many believe that asset inventory is the first core requirement. IEC 62443 subsection 2 subsection 1 states that it requires asset inventory and identification, meaning asset owner responsibilities. Well, still in ISC, but this one in SR 7.8, it mentions the detection and unauthorized access. NIST 2 directly mentions the requirement of having asset inventory as part of risk management. This is in Article 21, Section 2. Stellar does this by automatically building an OT asset inventory through its agent deployment and identifies ICS software versions. All three regulations mention the importance and need for logging, monitoring, and audit trails of OT endpoint devices. IEC mentions the security monitoring, event logging, and alerting, while NIST 2 talks about the importance of incident detection, logging, and then the reporting aspect as well. And finally, ISO 27001 requires logging and monitoring. As you've seen from the Ramsha's quick walk through Stellar 1, Stellar helps customers fulfill this as it logs every security event across its endpoints, and it centralizes it all in a user-friendly manner in the Stellar 1 management server. Thank you for watching today's webinar. As you can see, it's been a lot of information, and the world of OT endpoint security is a scary place if not handled correctly. As we highlighted in a few of our examples, it can cost an organization millions upon millions of pounds. And in worst case scenarios, it goes beyond money, and it actually can have really negative effects on human lives. And this is why M.A.C solutions work with TXOne, as we believe that the TXOne Stellar solution can be used as a help to these customers that allows them to have greater levels of visibility and control over their OT endpoints. If you do have any questions, please feel free to reach out. You can see on screen now my email and phone number. And from me and Ramsha, just a big thank you for watching today's webinar, and we hope to hear back from you soon.
Thank you.